Hello, welcome to the Machine Learning at Home. Today I will speak about very interesting method which allows you to compare two frequency distributions. A very common task in many fields of science and practical data learning. You will need to compare frequencies, like how many things of one sort, how many things of another sort, and again the second distribution with the same things but with different counts. So how to make this comparison? For comparison I mean like some numbers which tell you how close are these two distributions. Plus, it will be very nice to know how statistically robust these similarities or dissimilarities are. So let me introduce small package which allow you to compare these frequency distributions on a base of some so-called entropy measures. So let us load the package called KLZ tools library. KLZ tools. So in my case, this is already installed, but most likely this is new package. It is not installed in your system. In that case, you will first run the command like install .packages and then KLZ tools in quotes. This is important. In my case, I don't run it. I simply go to the second part, to library KLZ tools, but you probably will need install it first. Anyway, so I already installed it and it's already loaded in my system. Now it has like very few commands within, and the command which I run will have a same name, KLZ tools. But first I need to prepare my frequencies, and I will use the same iris data because it's kind of easy to obtain, but I need to do some preparations. So first of all, I will separate one of characters of irises, namely sepal length. So this kind of, well, sepals in a flower, measure it in some lengths. And remember, there are three species of iris. So first of all, I will make variable cc, which will be from cutting the sepal lengths, iris sepal dot lengths, in 5 intervals. So I will have kind of variable which is not numerical anymore, but kind of, well, quantitative variable made into qualitative variable. So interesting, cc variable. And then I will count frequencies of each of these 5 conditions per each of 3 species. So how to count frequencies in R? Command is very simple, table. So like make a table cc, and then for second argument I will need a species name, iris species. Okay, so this is my table. So look on it. These are my intervals. On the left side you see 5 different intervals, so lengths of sepals from 4.3 to 5.02, and Setosa has 28 of data points with that particular length. Versicolor has only 3 and Virginica has only 1. So looks like species are different by presence of these different intervals of lengths. But how to prove it, how to measure it, and how to prove that these differences, if any, are statistically significant? Let us use these KLZ tools. So first of all, I will need to separate 3 different frequency distributions. So I will make one distribution for Setosa, one for Versicolor, and one for Virginica. So Setosa, I call it Setosa CC, for example. And I need some technical additions. So I will need like a first column of that table, but I will also need to remove names of character and a kind of technical things. I will need 1 to my frequencies because these methods, most of them actually, do not digest zeros in data. So I will simply add 1 to all data points. Okay, so I will use command unname to remove names of intervals which are on the left side of that table, and we'll use the same table of cc iris $ species, and will also from that table I will separate column number 1. This is column number 1, and we'll put a second parenthesis here because I will need to unname all of that, and we'll add just one to kind of remediate the problem with zeros. So this is my setosa cc. Okay, and how it looks. Tosa cc. Very easy. Just 29, 22, 211, because I added ones to each of these data points. So not 28, but 29. And the same way I will use for making two other variables. So I press arrow up and replace some names. So like a second will be versicolor. And then I will need a second column in that case. And a third will be Virginica. And I will need a third column for that. So now I have 3 different frequency distributions, and now finally I will use command KLZ tools to compare setosa cc, so frequency of different lengths of sepals within setosa species, and frequency of different lengths of sepals within versicolor species. Okay, so this is my command. Very easy, I think. Yes, because I didn't put the right letter here. Versicolor. I double check. Okay, and we have lots of numerical outputs, and if you look on them, you will see they are kind of uniform. So first of all, you will have KLZ. This is a main divergency measurement, 0.9, which is kind of high. And then you will have so-called confidence intervals. So most important, if you look on the confidence intervals, that intervals must not contain 0, because if it contains 0, then there is no difference. Even if there is some difference in the first place, if interval includes 0, then, well, 0 is statistically put into this interval, so your difference is statistically does not exist. This is why we need these confidence intervals. So, in accordance to my KLZ tools result, difference exists, and it's statistically significant because interval goes from 0.4 to 1.6, and 0.9 of course is within of these two numbers. So this is difference between setosa and versicolor, and if you remember, setosa is most outstanding species of these 3 ones. So let us check like 2 more close species, how it will look. And these are versicolor and virginica. So these species are more close to each other, and while I suspect we have a less divergence, and maybe confidence interval will include 0, but I don't know. Let us check. Okay, so we go up again to see these first numbers. Yes, of course, the divergence is 0.5 versus 0.9 in the first case. And confidence interval, luckily for us, starts from 0.09. So still there is a difference. And confidence interval does not show that 0 is within, so difference exists, statistically exists, and is about 0.5. So this is how to use KLZ tools for measuring difference between 2 frequency distributions. These distributions occur almost everywhere in the statistical world. Like if you count anything by numbers, if you count whatever you like to count, you almost always need to compare 2 different counts, and KLZ tools will help you in these comparisons. So this is it for today. Thank you so much.